Hi, since I'm working on a project which uses company knowledge in a chatbot, I want to help everybody else to define the best strategy according to the use case to teach somehow AI models to use this data and to give us more specific responses using this knowledge and this data. So in this way, when you will have this problem, you will know how to navigate the whole landscape of solutions available and to know which strategy will be best for your data and your use case. For the start, we have to clarify the following concepts. The context window. So the context window, you have to think of it as the memory of the LLM, the active memory of the LLM, not the knowledge that he has accumulated during training. So this is the active memory which he uses when it is talking to us. And how it is working, it's normally split in 3 sections. The first section of the memory is called system prompt. And here it has the general instructions that it will use along the conversation. Then it has the user prompt. So it's actually all our questions that we are asking during the conversation. And then the completion, which is the AI answer. So all this is called context window, and it has a limited size for each model. Then I want to introduce the concept of fine-tuning. This is some sort of light training. So on top of the initial training that each model has been through before it was released, you can do a after-release training with a smaller set of data, which should look like a dialogue. So it's a pair of user message and AI answer, and we have to feed to the model many of these pairs in a special interface, and it looks like this. So for instance, for OpenAI on the platform, it's something like this. It's you choose a model that you want to customize, and then you will upload here, drag and drop your data. So it's not something very sophisticated, but it's a special function that many of the providers of LLM will offer you, and you can use it to alter the way the model is behaving, so the style, the tone of answering, and even the logic of the model. So it depends on the training data that you fit into it. So at the end, after this fine-tuning is finished, you will have a new version of the model customized to respond in your style and with your logic. But this is not a simple process because this data has to be very good quality for the process to be successful. Otherwise, you can just ruin the model and it will be just less than it was before. And then the last concept I want to introduce is called RAG. This stands for Retrieval Augmented Generation. And what it means in very few words, it means that we have a large amount of data that we want to feed into the model, but we cannot do that because it's bigger than the context window. So then the RAG process, what it does, it's splitting the big data in small chunks. It will look to what the user prompt is asking. So it will look to the question of the user, and then it will try to match this question with the most relevant parts of data. And it will take just these parts of data and will feed them into the system prompt or somewhere in the context window, doesn't matter where. And it will answer looking to this data to give a grounded answer using this external knowledge. Okay, so now that we understand these 3 strategies, let's see what we can use for which type of data that we have. So if we have a small amount of data, and doesn't matter if it's dynamic or static. So dynamic means, for instance, meeting minutes that we have every week, new meeting minutes. So we have a lot of new data all the time. This means dynamic. If we have a procedure which we update once 3 years, that is a static type of data. Yeah, but no matter if it's dynamic or static, if it's a small amount of data that fits in the context window, we just put it in the context window. This is the simplest way, and if we know all the time we are interrogating the model only about this topic of this procedure, we can put all the time in the context window the procedure, and then when we, like here, you see in the system prompt, we give instruction about the procedure and the way it should answer, and then it will always know the procedure, so it will learn, it will know this procedure, and it will refer to it in its answer. If the data starts to be bigger and it will not fit anymore in the context window, then we have two alternatives. If the data is quite dynamic, we have to use RAG because we cannot train the model again and again every time we have a new meeting minute. So for all these use cases, when you have bigger data and it's dynamic, we have to use RAG. For the rest, we can use fine-tuning. So if we have a lot of procedures which do not fit in the context window, we could also use fine-tuning. But again, with this caveat that it might change the way it responds. So this won't fit any bill. And I have another separation more about the type of use case, which we are going to see later. And then if the data is very large, then we cannot use the fine-tuning anymore anyway, and we are going to use RAG again. Also, on large amount of data, not only that fine-tuning is very costly, but it's also difficult to be sure you have a clean set of data. So it's very labor intensive to provide good set of data, because if the data is bad, the fine-tuning results will be very bad. So with large amount of data, it's very complicated. Okay, and now let's talk about the use cases and the type of use cases. So we discussed about the data, now we discuss about the use cases and which would work for what kind of strategy. So we can have expectations to have a stable behavior of the model or a more flexible behavior of the model. So this we have on the x-axis, and on the y-axis we have the type of knowledge or the type of tasks we expect it to do. So it can be knowledge-driven tasks or reasoning-driven tasks. And to be more explicit, what does it mean in terms of practical examples? So a corporate HR policy bot, this is something that is knowledge-driven, because it must know all this procedure to the letter. So it has to know very much all these details. But on the other hand, it has to be very stable as behavior, because this is very touchy area, and you want to have a tone and a style and everything that would fit an HR person. So this is a good case for fine-tuning to have this part of behavior like a HR person, and the logic and how it would respond via fine-tuning, and then the RAG for the policies and all the dynamic part, which may change more often and may be very big. And in there you can include legislation and other stuff, not only internal policy. So you can have everything up to date in the responses of the bot, because legislation can change and then you don't have it in the initial training data of the model. But if you have RAG, you always take the fresh data. Then other use case can be when we need stable behavior and reasoning driven tasks. So this can be a insurance claim processor, for instance. So in this setup, we need to have very predictable. So we cannot do much guesswork. So we have to be sure this acts really like an expert in this, and not only like a generic expert in this, but like an expert in insurance claims from our company. So we want this behavior to be very, very stable. And also this is more a reasoning driven task. So it will get these claims, but it doesn't have to consult a lot of external data or anything like this. So we can train it on all the cases and claim cases that were in the past. So it will behave and it will know how to reason about. Yeah. Because it has to take decision, logical decision, or at least to give advice about. Yeah. So this is very interesting. You can combine it with a RAG if you really want to refer to some external case or something like this. But if you have this in the training data, you might have the references anyway in the fine-tuning data. I mean, but the main here emphasis is on fine-tuning. On the opposite range of the scale, we have knowledge-driven task and flexible behavior. So this can be like a product catalog chatbot. So in this case, there are no specific rules about a product catalog. So we just need information and fresh information, up-to-date information about product. And products can be very, very volatile. So you change them all the time. There is a lot of information, tech specs, variants, pricing, and so on. And special pricing can be very volatile, manual comparison sheets. So all of this means there is a lot of data, a lot of dynamic data, and we don't have rules and regulations about it. So there is no guardrails on behavior. And when we have flexible behavior but reasoning-driven tasks, again, we don't have to put guardrails on that. And in this case, we can use context because we don't have a lot of data either. So when we say knowledge-driven task, you have to think, okay, we need data, we need knowledge, external knowledge, but in this case, we don't. We need reasoning. So just an example is, for instance, a compliance risk reviewer. In this case, we have policies which are knowledge indeed, but these usually are small pieces of knowledge which you can fit in the context window. So this is a bit related also to the size. And we again need kind of flexible behavior here because there is no regulation or something like this. These are internal policies. Or even a better example, which is not related to compliance, project governance assistant, which is again, about which will have as a knowledge company project management methodology, standard escalation metrics, definition of KPIs, things like that. And then he will have as dynamic documentation, like what we do, what we feed him as a user, like meeting notes, risk log of the week, and things like that. So now, if you have a use case, you can use such a matrix to try to map it from the data size perspective, from the data dynamics perspective, and from the behavior of the model. So it will be much more easier for you to choose the strategy you want to use for your data. Thanks for watching, and if you have questions about it, let me know.